In 2007, Gary and I formed San Clemente Green to promote a sustainable future for our community. By 2010, our work with the city resulted in a sustainability action plan that guides programs and policies to this day.
San Clemente Green led the grassroots effort to shut down San Onofre Nuclear Generating Station, also known as SONGS. It all started when we attended a public SONGS meeting. We witnessed a bold statement being made by a senior project manager. His name is Rick Busnardo, and thanks to Ace Hoffman, who also edited this video, he captured this historic moment that changed our lives from that point forward.
I get several phone calls from folks that I've known for many years, both that are former managers like myself, and a lot of them that are employees, that say we don't have a safety conscious work environment. And say they're afraid to come and talk to you folks.
A lasting relationship developed with Rick during the shutdown period, and we were pleased to catch up with him again recently. We knew it would be important to document some of the nuclear waste issues we face today with the man who actually built the canisters it is stored in. We learned some new things you'll definitely want to know as we navigate an uncertain future with 3.6 million pounds of the deadliest substance known.
Rick arranged for us to meet at his farmhouse. A casual yet sometimes boisterous conversation ensued with some significant highlights we are grateful to be able to share with you now.
Rick followed in his father's footsteps as a mechanic. His interest took him through a progression of advancements leading to the 25-year career with Edison as the project manager responsible for the on-site production of their 37 nuclear waste canisters at San Onofre. Always the perfectionist, Rick established the most reliable quality assurance program that existed anywhere else in the country. He is proud of the fact that he insisted on SCE hiring an independent, full-time American Society of Mechanical Engineers inspector to oversee his work, not just the Nuclear Regulatory Commission and Edison inspectors. He was let go at that point because of his courage to expose the fact that employees feared retaliation for reporting safety concerns.
Inspection standards declined when Rick left. No independent inspectors oversaw production after that. Rick was dismissed in a shameful manner, perhaps to silence others, but others came forward because of his example, and they forewarned us of the new steam generator fiasco, which ultimately took down the nuclear power plant for good. Rick was a steadfast person of conviction who stood by our cause throughout the shutdown period, and he paid a price for it. I trust him as an honest person of integrity, so I was anxious to get a few questions answered. I started right off on a hot topic that was once common knowledge, but now is a matter of contention. What does retrievability mean in his world? Was SONGS required to demonstrate the ability to put a welded canister, not loaded, back into the SFP, unweld it, and then weld it back on again? That's what I was told before we found out it's not really safe to put the fuel back in.
The answer is yes.
The answer is yes.
Yeah, we did it with water jet cutting. We put the canister in there. We didn't load it with fuel, of course, which is the regular canister was welded.
Yeah.
And we had to go in there with a water jet cutter while it was underwater and cut the weld so we could lift the top off. So if there was fuel in there, we could unload the fuel and put it back into the pool. We didn't put fuel in and do that, but we did it. You know, just that's all part of the NRC requirement.
So
all manufacturers have to do that. I mean, we have to have the equipment on site to be able to do that too.
So
now it's useless now because we don't have a spent fuel pool.
Yeah.
That's not even something that can we do it or not? We have to be able to do that. Period. End of story. One of those canisters failed, we've got to be able to retrieve it, pull the fuel out, and put it into a new canister. Period.
So how do we do that without a spent fuel pool?
You can't. Because you got neutron radiation. It goes right through you. It kills you. The neutron's the bad stuff. You got to have fission for neutron radiation. That's what you had at Chernobyl, right? Why they had to get out of there, because all those particles went out in there, and there's still fission, right? And that fission causes neutron radiation, and neutron radiation is what goes in one side and out the other. It kills what's ever in between. Fission comes from spent fuel. If a canister fails, we have no way to retrieve the fuel. Period. End of story. That's your headline. That's all. That's as simplistic as it can be.
But then what happens? What if we don't have a way to solve the problem? What happens in the environment? What results?
Well, there's a bunch of things that happen. Let's say, hypothetically, one of the welds fails in a canister, or from crevice corrosion, or torsional stress, or electrolysis, or whatever. You develop a hole in there. Right now, the what do they call it? The nuclear critical thing they used to always talk about was a canister filling up with 1/3 of water.
Yeah.
Fills up with 1/3 of water, becomes bad. I mean, it's really bad. But if it develops a hole or a crack or something like that, then you're going to, get radioactivity that's going to come out. Okay, your dosimeters or whatever the hell they got there that measures the radiation, you're going to know that. Now, does the crack propagate? Does it get bigger? Does it because of the heat or whatever? Does eventually there get enough water in there? Because these things, you got to understand, are air cooled. And now you got ambient air that's maybe it's 40 degrees one day, maybe it's 100 degrees the next, and what happens is that metal keeps stretching. If you could get do like a microscopy or look at a piece of metal, at the molecules in the metal, they're moving all the time, man. They're hopping. You get them hot, they grow, they shrink, they grow, they shrink. So you get what's called torsional stress. Torsional stress is like the coat hanger. Keep bending back and forth, eventually breaks. Now that canister is under a lot of pressure with 300 degrees. Now, if it goes ahead and it gets wet, or it leaks, or whatever, I don't know what the consequences of that are. I have no idea.
Yeah.
I'm not. You'd have to talk to some scientist but I know it's bad. The canisters, you got to remember, have 3 circumferential welds that goes all the way around the canister, and 2 longitudinal welds. In other words, a plate that's rolled, or an 8-foot plate, and we weld it longitudinally, and then we round it up. We put the 2 together, and then we do a circumferential weld, another circumferential weld for the cap on top, and another one. So you got, I don't know how many feet of weld that is, but it's a lot of weld. Yeah. Just so we understand what attacks metal. There's electrolysis, that's dissimilar metals. Take 2 pieces of metal and weld them together. One that's less noble and one that's more noble, one is going to plate the other, especially in a chlorine environment. Okay? Then there's what's called crevice corrosion. Crevice corrosion is probably your biggest enemy. Because crevice corrosion is an example is if you go out and take a piece of steel in your backyard at San Clemente and write your name on it with just a black marker, right? And then come out later on and a week later and take some acetone or whatever on, take the black marker off, your name will still be written on there. The reason for that is it's called crevice corrosion. The chlorine gets underneath the marker and starts eating the metal, etching it. Oh. Now, over a long period of time, it gets pretty nasty. Also, crevice corrosion likes metal that's rough. If it's on a smooth surface or it's a weld or something like that, the chlorine gets in there and actually eats it. Now, these welds will give away. Something's going to give away. Something always gives away in metal. There's no metal that lasts forever, period. That's the story. Especially in a saltwater chlorine environment. Metal's worst enemy is chlorine. It's bad. Hey, ask anybody who owns a boat. God, if there was an earthquake or a tsunami or one of them started a leak, which is going to happen probably before the other 2, but you don't know. We're losing our full core reserve. We had to put the fuel someplace, or the plant was just going to shut down. We couldn't keep doing refueling and taking 90 fuel bundles and put them in the fuel pool. There was no place to put them. They had to go into canisters. So that was my short thought, because I'm like work for SCE and I want to keep the plant going and all that kind of stuff. So they asked me to go out and look at all these different canister plants, outfits. There were 5 of them at that time, and I can't remember the names of them. I know Holtec I ranked as the worst, which is the one they're using right now. And I didn't like Holtec because I thought they were basically shoddy and they were all welded. And I didn't like the idea of a weldment being in 300 degrees because of the welds, the crack and all that. And I thought it was just bad. And also I didn't like the quality control. And it wasn't only them. It was the other 4 can. The best one I thought was transnuclear. And the reason I like transnuclear because it was mainly all mechanical. The bundle bolted together, and it was all, it looked like it was a lot more safer than all the other ones. And I like the transnuclear people. I thought they were on the ball. They worked for Areva, which is a huge manufacturer. But what I insisted on at the plant is that we build it using an ASME end stamp. Every manufacturer will say they build it under the ASME code, but they don't put an ASME end stamp on it. I could build it under any code, you know, see what the code says and go do it. What an ASME end stamp gives you is an independent, what's called an ANI, authorized nuclear inspector. He's independent. He works for ASME, and he's in your shop, and he's inspecting everything you're doing, making sure it meets the code. You have your own quality assurance program, right? Your own Edison inspectors. They're doing the same thing, right? And he's doing it independently. So what I wanted was, if we were going to build canisters at Edison, and I use this term about 1 billion times, I didn't want to have the public think we had the fox in the hen house, so to speak. In other words, we're out there, you know, shooting from the hip. We got an authorized nuclear independent inspector. Now, it took about $1 million to get that program and get that ASME end stamp, and it was very hard to do. We were the only nuclear power plant in the world that I know of that had an ASME end stamp. There's no requirement for the NRC to end stamp them. The NRC's requirement is that you build it to the code. How stupid is that? You have to build it to, I don't know, section 3, division, I forgot what it was, division 1, whatever. You got to build it to the code, right? But you don't have to end stamp it. Now, I can assure you that those canisters that we built are exactly to the way they were designed. Now, whether the design works or not, that's a whole different story. And you know, if you look at Transnuclear's document, and I don't want to take that, but I think they're only good for 20 years. That's all Transnuclear will tell you. And I probably got that document someplace. When you look at where they put that damn fuel, it's the only place that they could put the fuel where they had some space.
Yeah.
They could have at least took it like across the freeway onto the mesa where it's higher or something like that, where it's no oceans, to take the ocean out of it.
Yeah.
They could have done that, but no, because it was the cheapest thing to do.
Mm-hmm. Yeah.
It will not be the federal government that does it, because they couldn't agree on the time of day, and plus, federal government's talking about 50 states with, 3,000-4,000 canisters. They can't,
Yeah.
There's no one solution for
All of them.
them.
Yeah.
You
And
know,
there's like 16 power
it's got to be a
plants.
state
Yeah.
solution. That's what you got to focus on. I wrote a letter and sent it to the CEO of the company and everybody in senior management, basically telling them that we can't be, worried about raising concerns for fear of retaliation. That's what's happening right now here at San Onofre. I knew it was doomed once I did that. I knew it was all over for me, but it's the right thing to do. And I always thought that, license for storage, and they're just doing that because they don't want to pay the fees for transport, because they're not going to be transported yet. They're going to wait 5-10 years, whatever, and transport it. Once I found out that, they're not going to license for transport, and this stuff is going to sit here like forever, and I went to Yucca Mountain and seen Yucca. I was actually at Yucca Mountain, walked into the big tunnel and all that, and seen how stupid it was and how ridiculous everything there was. And because you'll go through the military base, and you'll drive for about 30 miles, and all you see on each side of you is places that are all roped off for radioactivity. But once I learned Yucca Mountain isn't going to open, that was bad. Because I know as a engineer and as a machinist and as a person who understands metallurgy and so forth, that is not going to last 10, 20, 30 years. It's just not going to last. It can't. Not on the ocean. It can't do it. Nothing lasts on the ocean. Anybody who owns a boat can tell you that. I mean, even in a nuclear power plant, everything that was stainless and everything corroded and fell apart. We'd have to replace it every 10, 15, 20 years. It's just bad. It's just, and now we have no plan. Yeah. Nothing. Everybody's just sitting here ignoring it, hoping it goes away. We're going to be in a 9/11 situation here like we've never seen before in our life. Yeah. It says, how long is a canister expected to last? Nobody's going to tell you it's going to last 1,000 years. That ain't going to happen. And they aren't the pyramids. Nobody's going to say it's going to last more than 20 years. Yeah. I mean, with any credibility. Yeah. Nobody that's in the industry would say that. How long do you expect it to last? What are we going to do with it when it fails? The ones that we did were horizontal. They're in horizontal storage. Right. So you line up the canister with the overpack, the big concrete pack, and you got this big ram that pushes the thing in. Okay? Now, if the canister is not properly aligned with the overpack, or is a little cockeyed, for lack of a better word, and you go push it in, it ain't gonna go in. The ram keeps pushing, the canister picks up a gouge, the gouge starts working on the canister, and it goes ahead and in the case of canister 19, it ripped the wall. Now we looked at those gouges; they're pretty nasty. they were pretty huge. I don't know. Maybe it's okay, but the wall's a lot thinner in that particular canister. Now, the question is that the only one? You know, and we don't know. The only reason that we know is there happened to be somebody out there on the site that said, "Hey, what are you doing?" You know.
So
I mean, there's 37 installed there. Now, another example is Holtec. Holtec did the same thing when they were lowering a canister into their overpack. They had it cockeyed, and when they lowered that 24-ton canister, which like wants to go, you know, when they lowered it down and all the rigging went slack before it was in other words, the rigging was loose and the canister was hung up. You know, and they had to get it back out again. It gouged it, right?
Right.
Now, same case. There was somebody there that said, "What the hell are you doing?" Because the guy that's running the show doesn't want to be the idiot that says, "Oh, look what I did."
Yeah.
That's so true.
I mean, that's just, you know, and he don't know any better. He don't know that it's gouged or whatever. You know, he just lifts it up another inch, gets it loose, and lowers the rest of the thing back in. Nobody knows.
Right.
So I don't know. I mean, and does that mean anything? Well, it means the wall on the canister is thinner. All I know is it was reviewed by the NRC, and you know, a bunch of engineers pencil whipped it and they said it's okay, but it's pretty nasty.
Yeah.
It's a big, huge gouge.
Yeah.
Safety-conscious employees at Songs, like Rick Busnardo, alerted us to the dangers that the industry did not want revealed to the public. The importance of whistleblowers cannot be overstated, heroically sacrificing their own well-being for the good of others. Because Rick decided to come forward, concerned citizens came together to force the shutdown of an aging and troubled nuclear power plant. But then we were confronted by an alarming reality. Tons of nuclear waste left near a popular beach described as the center of the surfing universe, only 100 feet from the rising sea, with radioactivity lasting millions of years, menaces present and future generations.
San Onofre is a microcosm of this national problem, the mismanagement of lethal radioactive waste lasting millennia. As temporary canisters decay, a nationwide crisis emerges, and the race to avert a catastrophe becomes a stark countdown against time. The role citizens must play is essential to ensure public safety is the top priority, and not contractors' short-term profits. For our protection, we need to build a facility like those used in Switzerland, with a hot cell for transferring nuclear waste into long-term storage containers, protected by a building capable of protecting it from the forces of nature or terrorism. Please join this effort to prevent such a calamity and help us pass legislation that will demand a California solution that will set the stage for the rest of the country. Together we can do this.